The topic for today is series and parallel connection. The learning outcome is you should be able to 1. Define and explain series and parallel connection. 2. Explain the application of series or parallel connection. 3. List and explain the advantages and disadvantages of series and parallel connection. 4. Calculate the equivalent resistance of resistor connected in series and parallel. 5. Define the term equivalent resistance. Before proceeding with this lecture, it will be important to describe the principles of electricity using the series and parallel connection. There are two basic ways to connect more than two circuit components: series and parallel. The basic idea of a series connection is that components are connected end to end in a line to form a single path through which current can flow, while in a parallel connection, all the components are connected across each other's leads. In a parallel connection, there are many paths for current flow, but only one voltage across all components. You should also know that series and parallel resistor configurations have very different electrical properties. The figure of the connection is represented. Now move to the application of series and parallel connection. The application of series and parallel connection can be outlined as follows. 1. Series circuit connection gives us the opportunity to connect more than two loads to a common switch. An example of this is street lights. 2. Most of the electric components in our household appliances are connected in parallel circuits. There are some which are connected in combinations of series and parallel circuits. Note better. Resistors are said to be connected in series if they are connected to the same wire. Also, the resistors are said to be connected in parallel if they are connected across the wire. The voltage remains constant in a parallel circuit, and the current remains constant in the series circuit. We move to the advantages and disadvantages of the series connection. The advantages. 1. Series circuits do not get heated easily. Therefore, any dry or flammable object placed near the series circuit will not catch the fire in case of overheating of the circuit. 2. Voltage increases if the number of cells increases. 3. Cells connected in series give a greater resultant voltage than individual cells. Disadvantages. 1. In a series circuit, all the appliances are connected one after another. In case if there is any fault or break at one of the appliances connected after that will be cut off from the supply. 2. The more components there are in a series circuit, the greater the circuit resistance. Now move to the advantages and disadvantages of the parallel connection. Advantages. 1. In a parallel connection, the voltage remains constant. Therefore, each component in the circuit gets the same amount of voltage. 2. A new electric appliance can be connected or disconnected in the circuit without affecting the other components in the circuit. 3. The current is able to pass through different parts of the circuit if there is a fault in one of the electric appliances. Disadvantages. 1. A lot of wires is needed to construct the parallel connection. 2. The requirement cannot be reached when the exact same amount of current is required to pass through the element. 3. In parallel circuits, the voltage cannot be increased since the resistance decreases in the parallel circuit. Equivalent resistance of resistor connected in series and parallel. Now we are going to look at a question and then the solution to it. Consider a parallel connection whose voltage is 12. Resistor 1, 1 ohms, resistor 2, 6 ohms, and resistor 3, 12 ohms. 1. What is the total resistance? 2. Find the total current. 3. calculate the current in each resistor. Now, to find the total resistance for a parallel combination, you use the formula for the equivalent resistance, which is 1 over R subscript P is equal to 1 over R subscript 1 plus 1 over R subscript 2 plus 1 over R subscript 3. And since we're having 3 resistors, we have 1 over 1 ohm plus 1 over 6 ohm plus 1 over 12 ohms. Now the sum total we give is 0.8 ohms. Now the equivalent resistance, which is R subscript P, is less than the smallest individual resistance. That's the observation. 2. To find the total current, you use I, which is current, is equal to V, which is voltage, over R subscript P. And then which you find to be as 12 volts over 0.8 ohms, which will give you 15 ampere for the current. The third says you calculate the current in each resistor. Using the same formula, you have I is equal to V over R1 for the first current, which will give you 12 ampere. Then you have 2, I subscript 2 is equal to V over R subscript 2, which will give you 12 volts over 6 ohms to give you 2 ampere. The third will give you I3, that is I subscript 3 is equal to V over R subscript 3 for the third resistor is equal to 12 volts over 12 ohms, which will give you 1 ampere. When you add the 3, you have 15 ampere, which is equivalent to the value of the current when you calculated it at once using the equivalent resistance. Now let's go to the definition of equivalent resistance. The equivalent resistance of a network can be identified as a single resistor that could replace the entire network in such a way that for a certain applied voltage V, you get the same current I as you were getting for a network. The two simplest networks are 2 resistors in series, whose equivalent resistance can be gotten by adding their resistances to get the equivalent, or in parallel, which equivalent resistance R subscript E is equal to R subscript 1 times R subscript 2 over R subscript 1 plus R subscript 2. In a series circuit, the equivalent resistance is the algebraic sum of the resistances. The current through the circuit can be found from Ohm's law and is equal to the voltage divided by the equivalent resistance. The potential drop across each resistor can be found using Ohm's law. The power dissipated by each resistor can be found using P is equal to I squared times R. I is for the current and R is for the resistance. And the total power dissipated by the resistors is equal to the sum of the power dissipated by each resistor. The power supplied by the battery can be found using P is equal to I times E. For a parallel connection, parallel resistance is found from R subscript P is equal to 1 over R subscript 1 plus 1 over R subscript 2 plus 1 over R subscript 3 plus till 1 over R subscript n, which is till infinity, depending on the number of resistors present. And it is smaller than any individual resistance in the combination. Each resistor in parallel has the same full voltage of the source applied to it. Power distribution systems most often use parallel connections to supply the myriad devices served with the same voltage and to allow them to operate independently. Parallel resistors do not each get the total current, they divide it. The summary is that in a series circuit, all components are connected end to end, forming a single path for electrons to flow. In a parallel circuit, all components are connected across each other, forming exactly 2 sets of electrically common points. Then the third thing is that a branch in a parallel circuit is a path for electric current, formed by one of the load components, such as a resistor. The evaluation is that you should explain the series and parallel connection. 2. State 3 advantages and disadvantages of the parallel connection. 3. State 2 advantages and disadvantages of the series connection. 4. Find an equivalent resistance. Thank you. See you in the next class.